Hey class, just looking into the last few problems of the slideshow. If you take a look, this is the one we were just on. It was the other form of a system of inequalities. This one technically is not really a system because it only has one variable, but we're going to treat it like a system because if we are to break it apart, which we did in class, you see that there's actually two inequalities working at the same time. So what we're going to do is we're actually going to solve each one of them separately. This is going to open it up the idea of what values of A would work for the first one and what values of A would work for the second one. So let's go ahead and start with that. Now, this is the way I would do it. Because there's a negative in front of where the variable is, that's what I'm going to move. So I'm going to add A divided by 3 on both sides. This is going to help because it gets rid of any kind of negative value. And as you guys know, negative values will switch the inequality symbol. So it's better off that we just get that out of the way by adding to both sides. Okay, now on this side, on the left-hand side, this one's easy. We have a division, so we have to do the opposite, which is multiply. So we get A is less than 3, which, by the way, if we want to show it on a number line, right, we have 3 here, 4, 2, no equal signs, we have an open circle, and less than would be to the left, right, going towards smaller numbers. 2 is smaller, 1 is smaller, 0 is smaller, etc., etc. Over here, we have a little bit more work to do. In this case, first we have to subtract 1/2 across. Remember, we're subtracting, so this is not change. This is not case 2. Case 2 only happens when we multiply or divide by a negative number. So we actually get 1/2 is less than or equal to A divided by 3. And then like before, we have to multiply both sides by 3. So A is greater than or equal to 3 times 1 is 3, divided by 2. If you want to go crazy, we can even write it as 1.5. I know some of us like that. So 1.5 or 3 over 2 is less than A, or A is greater than that number. Take a look at the inequality symbol. We have 1.5 here, we have 2, we have 1. We do a closed circle because it's equal to it, and we want everything that's greater than. So A is going to be greater than that. So that's what that side is looking. Now, this is great, except that now we have to find out what works for both. One way that we can do this is I can take this one over here, and I'm going to add it on to the other side. So I'm going to find 1.5, which is right here. And I'm literally going to put this inequality symbol right here, there. So I'm going to go ahead and put a closed circle, and I'm going to draw an arrow going this way. Right? So now I have both right there. Guess what? This right here is the only range of numbers that would work, okay? Numbers that are greater than 1.5, but less than 3. So how do we write that? Good question, class, good question. We write it as A, right? A is going to be less than 3. Let me just go back and double check, right? Less than 3, open hole at 3, very good. And then A is also greater than or equal to 1.5. And that would be your final answer. Okay, let's go ahead and move on to another one. If we're taking a look at this, right, this is an SAT question. They gave you a graph, which I'm going to rough sketch it really quick right now. Don't mind it being awful. If you guys look, it is going to be parallel lines because they are not intersecting. We have a shaded region above, and we have a shaded region below. We also have two solid lines, nice and solid. And we're going to go ahead and label our graph, right? One inequality up top crosses at 4, and the other one crosses at -2. Okay, so if you look, here we go, which is good, right? We want inequality number 1, which is the top part. We'll split it in half. Inequality number 2, which would be the bottom one, right? So this one's going to be up here. This one's going to be down here. This is a tricky question, not necessarily in difficulty, but it will be difficult because it's a lot of steps. And that makes it tricky for many of us because when you start adding a lot of steps in, it kind of makes things crazy, which is fine. But first things first is let's identify the important parts, right? What's this y-intercept and what is the slope? If you look right here, the y-intercept is 4. I pulled that from the graph. If you take a look over here, right? It doesn't ever reach 5. It's the one before it. While we're here, let's go ahead and take a look at the slope, right? If you look, you have it at 4, it goes down 1, so that's negative 1y, and over to the right 3. And we can follow that pattern all the way down. So we have negative 1 in the y, positive 3 in the right, so it's going down 1, right 3, down 1, right 3. Over here, y-intercept is negative 2, and then the same thing, slope, right? So we'll start at negative 2, we're going to go down, sorry, let's cover my fingers. We're going to go down 1 and over to the right 3, and that's where our next spot is, and do the same thing over and over, right? Down 1, right 3. So the slope is actually the same, which is good. We just found that straight from the graph. Now here's where it gets a little bit tricky, right? Now we need to have the inequality. So remember, all inequalities, it would be nice if they're written like this, right? What this means is that it's taking on slope-intercept form, mx plus b, but I don't know what the inequality is. It's not an equal sign, it's not greater than, it's not less than, right? So there's going to be something involved there that's a little bit more, fruitful. But now what I'm going to do is I'm going to take all of the information I have and I'm going to plug it in. So I know it's y. I don't know the inequality symbol, but I know my slope is negative 1/3 x. I know that's plus 4. That's my first one. Second one, y. I don't know the inequality. My slope is also negative 1/3 x. And this time, instead of being plus 4, it's going to be minus 2. So if you look, I have my two inequalities right here. And here's what we're going to do. If you look, solid line, that's helpful. Solid lines means that it has to be equal to. That means I don't know if it's less than or greater than, but I know at least that on the line is equal to. Now what I'm going to do is, and I'm going to do this in a one-time shot, it's going to hopefully be a little bit easier. So I'm going to take, sorry about that. I'm going to take a point that's somewhere in the middle, right? This is the false region, or the not true for either inequality. So let's go ahead and take the point 0, 0, right? It's there. I'm going to test each equation, each inequality. So I'm going to take y, I don't know what this is, but I know it's partly equal sign, negative 1/3 x plus 4. And I also know y, don't know what the inequality sign is, but I know it's also half equal, negative 1/3 x minus 2. So here's my two inequalities, right? I'm going to test this out for them both to be false. I want these to be false. So later on, I'll be able to pick an inequality that makes it false. So using the point 0, 0, let's go ahead and test these points. Because remember, if we go back, 0, 0 is in the false region. So plug in 0, 0. I'm going to do them both at the same time so it's a little quicker. And remember, I'm just plugging in 0, 0. I want to now simplify. So anything times 0 cancels out, so the slope cancels on both sides. This is going to give me 0, some inequality symbol, minus 2. 0, some, I don't know why I did that backwards. Some inequality symbol, plus 4. So remember, I want it to be false. So we know that 0 is actually less than 4. But if I want it to be false, right, 0 being greater than 4 would be false. So I want this to look like this, right? So if I put this inequality here, the greater than, 0 greater than 4 is a false statement, which is what I'm looking for. I'm looking for those falses, right? I'm looking for the false. Same thing here. What would make this false? Saying that negative 2 is greater than 0. That's a false statement. That's what I'm looking for, right? The reason why I'm doing this is to find out what the inequality is, right? That's the only reason why I'm doing it. I want to know what the inequality is. Now I'm going to go back to this top line where it has the empty box, and now I'm just going to fill in what I have. These are the two inequalities. And everything else stays the same. Here's your first one. And here's your second one. Those are the inequalities that actually make up the system of the inequalities in the graph right there. All the information is pulled from me. I have my y-intercept, I have my slope. I have my slope, and I have my y-intercept. The hardest part is finding the inequality symbols. All right, guys, I'm going to post one more video on the last question. I don't want to make these videos too long, so I'll be right back.